Right, so another walking, talking mock, and this time we have the sample assessment. So these questions have been taken from previous exams. So yeah, let's go through them. Okay, question 1. So question 1, express this fraction as a single fraction in its simplest form. Okay, so the first thing I'm going to do is factorise every numerator and denominator until I can then, and I'm then going to add or subtract. So 6x plus 4, I can factorise out a 2, and I'm going to get 3x plus 2 over 9x squared minus 4, difference of 2 squares, so I'm going to get 3x plus 2, 3x minus 2, which is quite good because they're going to cancel. I'm going to actually use a highlighter. They're going to cancel because that's a factor of the numerator and denominator, and then I get 2 over 3x plus 1. Okay, now adding or taking away fractions, we know to do that we have to have the same denominator, so I'm going to multiply the left-hand fraction by 3x plus 1 minus 2 lots of 3x minus 2 all over 3x plus 1, 3x minus 2. So my numerator is 2 times 3x, which is 6x, 2 times 1, which is 2, minus 2 times 3x is minus 6x, minus 2 times minus 2 is plus 4. Now my numerator, my 6x and minus 6x cancel, and I'm left with 2 plus 4, which is 6. So this then equals 6 over 3x plus 1, 3x minus 2. Fantastic. 4-mark question solved in under 2 minutes. Okay, so we might remember this question from the numerical methods video I did the other day. So, part A says show the equation can be written as. So we've got to do rearranging equations, which is fine. And what we notice that they're factorised, okay? And we have an x squared, okay? So first thing as well I suggest we do is I suggest that we factorise this, okay? So I'm going to factorise, because I've got a 3 and a 4 and a 3, 3, 4, this is going to make 12. I'm just going to factorise the first two. So we're going to have x bracket x squared plus 3x. No, I'm going to factorise out an x squared, everyone. So x squared bracket x plus 3 plus 4 lots of x minus 3. Okay, and this equals 0. However, I'm going to move this to the other side. So I'm going to have x squared x plus 3 equals negative 4x minus 3. Then I'm going to put the negative inside the bracket. So x squared x plus 3 equals 4 lots of, and then multiply everything inside by negative 1 is negative x plus 3. Okay? Now, I know this minus x plus 3 is the same as 3 minus x. However, we want to show it can be written this way. And I know x plus 3 is the same as 3 plus x. I'm just going to rewrite this now with these in the correct way. So x squared is 3 plus x equals 4 lots of 3 minus x, okay? Because we're showing that. You know we know it's the same thing. However, let's do what they've asked us to show. So that means that x squared equals 4 lots of 3 minus x over 3 plus x. So x equals the square root of 3 minus x over, 4 lots of 3 minus x over 3 plus x. Therefore shown. Okay, now I do know that normally when we square root we have our plus or minus. However, we're just going to take the positive of this. Okay. Next. Okay, then we have used the iteration formula. So the iteration formula it says use x0 equals 1. So x0 equals 1. So I love these questions. So I'm going to put x0 equals 1. I'm just going to put 1 equals into my calculator. 1 equals. And then in my calculator, I'm going to write the square root of 4 bracket 3 minus ants over bracket 3 plus ants. Because this will help me. So square root fraction 4 bracket 3 minus ants over bracket 3 plus ants. That is exactly what I'm going to write in my calculator. Press equals and it gives me root 2. So x1 equals root 2. It wants 2 decimal places, so SD is 1.41. Press it again. Oh no. I have to do the whole thing again. Sorry, guys. Wait, then I'm going to pause the video. Yeah, and then I press equals again. X2 equals 1.198. 2 decimal places is 1.20. And then x3, if I press equals again, is 1.3099. 2 decimal places, 1.31. Make sure you round properly. If you're unsure of like this one, I hope no one puts 1.19, but maybe do the one before it and then do the rounded one just to make sure that you get those marks. So that's nice and easy, 3 marks for being able to type and round. And then part C. Okay, so that's A, B, and now C. It says the root of f of x equals 0 is alpha. Okay, by choosing a suitable interval, prove that alpha is this. I love this. I didn't realise this is just like upper bounds and lower bounds from GCSE. Well, the IGCSE. So 1.272. What's my upper bound? That's 1.2725. What's my lower bound? 1.2715. So now what I'm going to do is I'm going to do f of x, okay? So f of 1.2715 equals, and I'm going to substitute that into my original equation, okay? So when I substitute it into here, I'm just going to put 1.2715 equals, and then I've got an answer. So I'm going to do answer cubed plus 3 times answer squared plus 4 times answer minus 12 equals 0.008. This is -21. Okay. And then now if I do f of 1.2725 equals. So I'm going to have answer cubed, and then I forgot the rest of the question, plus 3 times answer squared, plus 4 times answer minus 12 equals 0.00827. I don't know why there's a comma there. ... Okay, so we can see we have a positive and a negative. So we need to actually write. Okay, so change of sign and f of x is continuous. Therefore, alpha equals 1.2727. Okay? I don't know where that other 7 came from. Sorry, guys. Okay. So there we go. Nice and simple. 8 marks. Okay, so question 3. What we have is a functions question. So for part A, we want to solve the equation f of x, which we've been told is this, equals to a half x plus 3. Okay. Now, I know what you're thinking, and I'm going to roll with what you're thinking. So we always do 2 lots of 3 minus x plus 5 equals a half x plus 30. And then we're also going to have two lots of negative 3 plus x. So we do the negative of the modulus. Plus 5 equals a half x plus 30. Okay, am I right? Is that what you've done? Okay, so then I'm going to solve this. I'm going to get minus 6 plus 2x plus 5. So that's 2x minus 1 equals a half x plus 30. And then I'm going to have 3 over 2x equals 31, 62. So x equals 62 divided by 3. And then I'm going to have 11 minus 2x equals a half x plus 30. Negative 19 equals 5 over 2x. Negative 38 over 5 equals x. Did everyone get those two values? Right, and then we can see from the question that x has to be greater than or equal to 0, so we reject this one. However, I just want to have a quick pause and just discuss this, okay? So we reject it. It means that when it crosses this, it only crosses once. How could that be? Now, if we have a look at this equation, f of x equals 2 lots of 3 minus x plus 5, what is our intercept here? My y-intercept?
11.
11?
Yeah.
Brilliant. This is 11, because this is when x equals 0. If I put 0 in here, I get minus 0. Okay, so 2 times 3 plus 5 is 11. So we know this is 11, okay? Now, if we have a look at our equation, we get half x plus 30. Okay, so that means my y-intercept here is 30. So this is going to be up here somewhere. Imagine this is 30 here, and this diagram is not to scale. Okay, so we're going to have our straight line here. So in fact, if I was to continue this, we can see that there's only going to be one, and of course it's going to be positive, okay? It tells us in the question, but that's why. You have to think logical. So the only one we accept is 62 over 3. If you left both, you would not get full marks for that question. Okay, so brilliant. Then the next part of the question says, given that the equation f of x equals k, where k is constant, has two distinct roots, state the set of possible values of k. Okay, I always love getting my ruler out. Two distinct roots means it crosses twice. Okay? So, okay, before I use my ruler, do we know what this minimum point is here? This is 3, 5. Okay? Told us in the equation. We can see here that this is 3, 5. So we know that we know that this is 5. Okay. And this is 11. Right, so let's get this ruler. So if my k, remember f of x equals k, so we're saying y equals k. If y equaled anything less than 5, would it cross at all? Does my ruler intersect? No. If it equals 5, how many times does it intersect? Once, because it touches, because that's like our minimum point of, like our turning point essentially. So we know for part C that 5 is less than k. And then if I went here, let's say this is 8, we can see it crosses twice. It crossed here and here. Okay, for some reason I can't use the lightsaber and the ruler at the same time. And then if I get to 11, it still crosses twice, so I can include 11. However, if I get to 12, let's say, it only crosses once. So then this is less than or equal to 11. Okay, and you can use your ruler for this. It's really simple. Okay, question 4. Give it a go first, and then I'll go through it. So, part 4i says integrate between 13 and 5, 1 over 2x minus 1. Okay, the first thing I'm thinking is I am going to have to do an assumption, okay? And I get 1 over 2x minus 1. So this is to the power of -1, isn't it? Okay, what do we know gives us the power of -1? Ln. Okay, so if y equals ln of 2x minus 1, okay, let's assume. If we differentiate this, we get 1 over 2x minus 1 multiplied by the differential of the bracket. Okay, this is chain rule. If I differentiate 2x minus 1, what do I get? 2. So I get 2 over 2x minus 1. However, I just want one lot of this. So I know I need to divide this whole thing by 2. That means I need to divide my original equation by 2. So therefore, the integral of 1 over 2x minus 1 with respect to x equals a half, because I've divided it by 2, ln of 2x minus 1. And then obviously our plus c. However, we don't need our plus c because we are now going to start putting values in. Now, if it wants us to write our writing your answer in its simplest form or exact value, we cannot use a calculator to help us. We've got to do this all in our head, and it's very simple. I will show you. So it's between 13 and 5. So once we've integrated it, it's now going to be between 13 and 5, a half ln 2 lots of 13 minus 1 minus a half ln 2 lots of 5 minus 1. Okay, so for the first section, 2 lots of 13 is 26, minus 1 is 25, so a half ln 25. So a half ln of 25 minus 2 times 5 is 10, minus 1 is 9, so we're going to get a half ln of 9. Okay, what do I know about the laws? I know that a ln b can be written as ln of b to the power of a. So a half ln 25 is the same as ln of 25 to the power of a half. So ln of 25 to the power of a half. Now remember, it's the modulus of this, so even though root 25 is plus or minus 5, we just take the positive, which is going to equal ln 5 minus ln of 9 to the half, which is root 9, which is 3. So I'm going to get ln 3, okay? And then we know the log laws. When we minus, it means we divide. So this is actually ln of 5 over 3 in its simplest form. And you can see I didn't use a calculator once for any of that. Okay then, so that was question I, part II. Let's use a different colour. So II I'm going to do over here. I'm just going to write it down. So we want to integrate between pi over 2 and 0 sine of 2x plus sec a third tan a third with respect to x. Did I write the whole question down right? Yeah. Okay, so I'm going to do that over here. So because we're adding in the middle, this is fantastic. Now I know what some of you are thinking. You're seeing second tan, you're thinking, oh yay, you know, this is a product. Well, first of all, we're integrating, so we're not worried about products, okay? But also remember, this part is in your formula sheet. Okay, sec-tan integrates to sec. Okay, and we have proved that before. However, or did we? I can't remember, or maybe that's pure 4. But don't worry, this in your formula sheet, that part. Sine, however, we know how to do, because it goes sine, cos, minus sine, minus cos. When we differentiate, we go this way. Integrate, we go this way. So sine goes to negative cos. So I'm going to get negative cos of 2x. And then remember, we divide by the differential of the bracket. So we need to divide by, if we differentiate 2x, we get 2. So we divide this by 2 over 2. Okay, I'll make it tidier in a minute. Okay, then sec tan integrates to sec. Okay, so this is plus sec, oh, sorry, I don't know where these x's went. Sec of a third x. Now remember, we need to divide by the differential of this. So a third of x differentiated is a third. If I divide a sec by a third, I'm actually multiplying it by 3. Okay, there we go. That is it. And then obviously our plus c, but we've got our box, so it doesn't matter. Now I'm going to substitute in everything. So minus cos of 2 times pi over 2 is pi, all over 2, plus 3 lots of sec, which we know sec is 1 over cos, so I'm going to go 3 over cos of a third times pi over 2 is pi over 6. Okay, then this is minus a cos, minus cos lots of 0 over 2 plus 3 sec, no, I'm not writing sec, I'm writing cos for my calculator. 3 over cos of a third times 0 is 0. Okay, so I put this whole thing into, I'm not going to put the whole thing into my calculator, I'm going to put each section into my calculator. Okay, so first of all, I'm going to make sure my calculator's in radians, angle, unit, radians. Okay, so cos, shift pi, is minus 1, okay? And then, so times that by minus is plus 1, divided by 2 is a half. Okay, so this becomes a half. Okay, and then I'm going to have 3 divided by cos of shift pi over 6. Put my brackets in. And I get 2 root 3, so that's plus 2 root 3. Brilliant. Okay, minus. Okay, cos of 0 is 1 divided by 2. So minus, this means it's going to be plus a half. Okay, and then 3 over cos of 0. 3 over cos of 0 is 3, so that's going to then be minus 3. Okay, because of this minus here, remember that. So now I'm going to have a half plus a half minus 3. A half plus a half is 1, okay? 1 minus 3 is minus 2, and then I've just got 2 root 3. So this equals 2 root 3 minus 2. Is that all it wanted? Use integration to find the exact value. And there is the exact value. Okay, question 5, 6 marks for differentiation question. And we can see it's quotient rule. So V, U. So V du minus U dV over V squared. Okay then, so differentiate this. We already did this. So if we differentiate U, we're going to get 10x minus 10. If we differentiate V, we're going to get 2 lots of x minus 1 to the power of 1 multiplied by the differential of the bracket, which is just 1. So we'll just leave it like that. And then obviously V squared is x minus 1 squared, which is to the power of 4. So let's start. V x minus 1 squared multiplied by du, the differential of u, which we know is 10x minus 10. Now, 10x minus 10 can actually be factorised. They both have a common factor of 10. Okay, so I'm going to rewrite this as 10 bracket x minus 1. Now, we noticed something straight away. Okay, but I'm just going to leave it like this. I could simplify it, but I'm just going to leave it like this for now. Minus u, which is bracket 5x squared minus 10x plus 9. And then dv, which is times 2 lots of x minus 1, all over x minus 1 to the power of 4. Now, actually, if I look at all my terms, I have 3 terms, don't I? 1 term, 2 term, 3 term, because this will multiply and simplify, this will multiply and simplify. All of them have x minus 1 as a factor. So actually, I can start by taking away an x minus 1 from everything. So now, on my numerator, I have 10 lots of x minus 1 squared minus 2 lots of 5x squared minus 10x plus 9 all over x minus 1 to the power of 3. Okay? Now from here, I will now need to expand and simplify. So x minus 1 squared, this is, I'm just going to do it a bit, I wouldn't do this as slow, but this is 10 lots of x squared minus 2x plus 1. Okay, that's going to give me 10x squared minus 20x plus 10. And then minus, I'm going to have brackets 10x squared, 2 times minus 20x, and then 2 times 9 is plus 18. So then this becomes minus 10x squared plus 20x minus 18. Okay? Everyone's still with me? So then, 10x squared minus 10x squared is 0, minus 20x plus 20x is 0, 10 minus 18 is negative 8. So, that's left me, that's left me with negative 8 over x minus 1 cubed. Sorry, I got lazy earlier. No, I didn't write that on each one. There we go. And then the question says, write it where k is a constant to be found. So k is actually negative 8. Nice and simple. Okay, I'll give you guys a 2-minute head start. So the function ex plus 2 is f of x and g of x is ln of x. It says state the range of f. So the range of f means my y. So if I substitute in e equals 0, what do I get? If I put 0 here, okay, so if I was to put 0 in here, e to the 0 plus 2, I get 3. Okay, however, we know with the graph of e looks like this. And we know that it crosses at 1. However, I do have an asymptote on the line y equals 0. Okay? So we know for the normal graph, everything has to be bigger than 0. So even though normally we put in a value of x to see what happens, remember that even though we put this value in, if we were to put like e to the negative 10 plus 2, we're going to get a really small, we're going to get a really small number. 0 point something. Okay, so you have to remember that our graph is going to shift. So our asymptote now, because we've translated it up to, is now going to be y equals 2. So we know then that f of x always has to be greater than 2, because that's going to be our new asymptote line. Part B says find f of g of x given your answer in its simplest form. Okay, so g of x is ln x. So f of g of x means everywhere there's an x in f, we're going to put in ln x. So I'm going to have e to the ln x plus 2. Now, I know that e to the ln x is just going to cancel to x. So this is x plus 2. And that is what f of g of x equals. So nice and easy, 2 marks. And then it says, find the exact value of x for which 2x plus 3 equals 6. Okay, so in our f, everywhere there's an x, we're going to substitute in 2x plus 3. So I'm going to have e to the 2x plus 3 plus 2 equals 6. So e to the 2x plus 3 equals 4. So now what am I going to do? I'm going to ln both sides. So I'm going to have ln of e to the 2x plus 3 equals ln of 4. So 2x plus 3, I'm going to take out the brackets actually. 2x plus 3 equals ln of 4. So 2x equals ln of 4 minus 3. X equals ln of 4 minus 3, all divided by 2. Okay, so we can keep it as this, but just another thing. This is the same as x equals a half ln of 4 minus 3 over 2, which we know x equals a half ln 4 is the same as ln of 4 to the power of half, which is ln 2 minus 3 over 2. Now, in the mark scheme, either solution is accepted, okay? Either of those. So, but just a reminder that we can do this. Okay, then part D says find f minus 1 stating its domain. Okay, so nice and simple. We are going to say let x equal e to the y plus 2. And what am I going to do? I'm going to rearrange this to get y equals. So x minus 2 equals e to the y. I need to ln both sides. So ln of x minus 2 equals ln of e to the y. So y equals, because they're going to cancel, ln of x minus 2. So that means f minus 1 equals ln of x minus 2. Now it says state its domain. Now, do you remember when we did inverse? Whenever we do inverse, if we have a function f of x, shall we say, and we have the domain, which we know is x belongs to the real, because it told us in the question, and then we have our range, which is f of x is greater than 2. Whenever we do the inverse, they switch, remember? So our new domain is our old range. So this would be f of x is greater than 2. But we wouldn't write f of x, would we? Sorry, we'd write, because domain is x, so x is greater than 2. And our range for this would be the f of x belongs to all the real numbers, okay? So in this case, we're literally just going to write x is greater than 2. Okay, so remember that fun fact. Right, and that's because when we do the inverse, we reflect in the line y equals x, okay? Brilliant. Then it says, and we're going to need this now. On the same axis, sketch the curves y equals f of x and y equals f of x minus 1, given the coordinates of all the points where the curves cross the axes. It's fantastic news. Okay, so step 1. I'm going to use a ruler. Well, I'm not, but you are. X and y. Okay, so e to the x looks like this. And this, f of x equals e to the x plus 2. We discussed earlier, we translated it, and normally crosses at 2. I just realised I've just drawn e to the x. Right, don't worry. This is e to the x. Okay, I need to move this higher now, because we have that asymptote, don't we? There we go. Okay, so now I've drawn f of x equals e to the x plus 2, and I have an asymptote on the line y equals 2, and I know that this is 0, 3, because I can substitute in 0, and then I'm going to get e to the power of 0 is 1 plus 2 is 3. Now remember, now I don't need to know. I know that f of the inverse is ln of x minus 2, was it? I can't remember. Sounds about right. Yep, ln of x minus 2. Now, I don't really know how to draw that, but it doesn't matter, because what I do know is I can reflect in the line y equals x. Okay, so if you're ever not sure how to draw it, if you know how to draw one, you can always draw the other, because we're now going to do a reflection. And I'm going to draw this in a different colour entirely, green. So I reflect this. So if you think, in the exam, you can ask for tracing paper if you need to, okay? When you reflect this, think about what's going on. I always, you can't see my hand, but my hand's on the screen, on the line, and I'm like looking at how it could look. And I know that this reflection now, we are going to have an asymptote here in the line x equals 2. And it's going to look exactly the same, just opposite. And it's going to go like this, okay? Because it's complete reflection. So this point is going to be 3, 0. Okay, now some people make the mistake of coming into this quadrant, but you can see here, there was never anything in this quadrant, so why would it be reflected in this quadrant, okay? Really think about the reflection in this diagonal line. Fold your piece of paper in half there and see if it matches it should. If I was able to fold this on this line, okay, imagine it was ink, and if you folded it once, it'd make an imprint. It should make the same imprint. I hope that makes sense. It's really difficult showing how to do this on the iPad. So there we go. This was 14 mark question. And we learnt a lot. Okay, so question 7. So the point P lies on the curve of the equation x equals 4y minus sine of 2y squared. Given that P has coordinate x, y, where P is a constant, find the exact value of P. Okay, so that's easy. For part A, x coordinate is going to equal 4 lots of pi over 2 minus sine lots of pi, 2 times pi over 2, which is just pi, all squared. So I'm going to get x equals 2 pi all squared, so x equals 4 pi squared. Perfect, so that is my coordinate P. So I know I have 4 pi squared and pi over 2. So nice, easy 1 mark. Part B. It says the tangent to the curve at P cuts the y-axis. If it cuts the y-axis at the point A, that means my x equals 0. Okay? So, and we need to find the tangent to the curve at P. Okay, so the tangent to the curve at P means I need to differentiate. So if I dx by dy, differentiate the bracket, I get 2 lots of 4y minus sine of 2y. Multiply that by the differential of the bracket. So 4y differentiated is 4. Minus 2y differentiated, sine cos minus sine minus cos. So minus sine differentiates to minus cos. So this becomes minus cos 2y, and then I need to multiply this by the differential of the bracket as well, which in this case is the 2y. So multiply it by 2 is 2 lots of this. Okay, so there we go. Nice. We've differentiated this. So now for dy by dx, which is our gradient, it's going to be 1 over all of this. Okay? So 2 lots of 4y minus sine of 2y, 4 minus 2 cos of 2y. Okay. Now I need to find the gradient. Okay, so I actually made a mistake when I did this the other day. I'm so used to substituting x that I substituted in 4 pi squared. And I got some really random thing. And then I realised these have y's. So of course I need to substitute in my pi over 2. Okay, so my gradient of my tangent is 1 over 2 lots of 4 lots of pi over 2. And again, guys, I am going to, I'm just going to write this out for your purpose, and then I'm not going to put it into a calculator. I'm going to work it out because normally we want exact. Okay, so I've got 1 over 2 bracket 2 times pi, 4 times pi over 2 is 2 pi. Okay. Sine of pi is 0, if I'm not mistaken. Sine of shift pi, but let's use a calculator just in case. Yep. So that's minus 0. And then I get 4 minus cos minus 2 cos pi. Okay, but I'm sure that cos of pi is 1. So I get minus 2 lots of minus 1. So this is going to be 4 plus 2 is 6, times 2 is 12, times 2 is 24. So my gradient is 1 over 24 pi, and I'm going to leave that exact. Okay, so I have my gradient of the tangent to the curve at P, and I have my coordinates 4 pi squared and pi over 2. This is of P. So the tangent to the curve at P cuts the y-axis at the point A. Okay, so the first thing I'm going to do is I'm going to work out the, y equals C. So y, which is pi over 2. Oh. Pi over 2 equals my gradient x, which is 4 pi squared, plus c. So pi over 2 minus 4 pi squared over 24 pi equals c. Okay. 1 over 6. So pi over 2 minus pi over 6, shift pi over 2 minus shift pi over 6, a third pi. So c equals pi over 3. So I get y equals 1 over 24 pi x plus pi over 3. Okay? And then it says, use your calculus to find the coordinates of A when x equals 0, so it's just the intercept. So the coordinates are 0, pi over 3. Brilliant. So there we have it. Nice, easy, 6 marks. Okay, question number 8. Give it a go, and then I will also do it. Okay, so question 8, part A. In a controlled experiment, the number of microbes N presented in a culture 2 days after the start of the experiment were counted, and they've given us a thing. Show that this can be expressed. Okay, so we just need to do logs to both sides. So log N equals log of AT to the power of B. We know that's the same as log N equals log of A plus log of T to the power of B, which can be written as log N equals log A plus B log T, using all the log laws. Okay, and then you can put therefore shown. Now by this we can clearly see that we've got the log T, log T. So this means, and we will need this further down in the question, our plus C is our log A, and our M, which is our gradient, is our B here. Okay? So it says, show that this relationship can be expressed in this form given M and C in terms of the constants A and or B. Okay, so then we just need to write C equals log A and B equals M. Okay? So then part B says figure 2 shows the line of best fit. N plotted against log T. Use the information provided to estimate the number of microbes present in the culture 3 days after the start of the experiment. Well, the best way to do this is to use the graph to help us find our values of C, our values of A and B, so that we are then able to put them into the original equation. So first of all, what do we know about C? It's our y-intercept. So our y-intercept here, if I zoom in, I mean, I know you guys can't zoom in this far, but you know that this is 1.75. Okay? Because that's in between 2 and 1.5. And then we have 1, 2, 3, 4, 5. So this must be 1.80, 1.85. I'm assuming on yours when it's printed, you're probably going to go for 1.85, maybe 1.83. Should we just go for 1.84 or 1.85? Let's just go 1.85. Okay, remember this is an estimate. Okay, so we know that our y-intercept is 1.85 equals log A. So how do I find my value of A? I know that 10 to the power of 1.85 is going to equal A. So A equals 10 to the power of 1.85, which is 70.7945 ... So A equals 70.8 free significant figures. And then we know that our B is our gradient. So I'm going to pick 2 points on my line of best fit. So I'm going to choose this one, which we know is already 0, 1.85. And then to make it easier, I'm going to choose, I'm probably going to choose this point here, okay, which is 1.2 and 4.5. Okay, so how do I find the gradient? My difference in y minus my difference in x, which is going to be 4.5 minus 1.85 over 1.2 minus 0. So I get 2.20833, which is 2.21 to three significant figures. Okay, so that means my formula is n equals A, which we worked out, 70.8. T is our time, okay, so we can leave that, to the power of 2.21. The question asked us for 3 days, so n equals 70.8 times 3 to the power of 2.21. So 70.8 times 3 to the power of 2.21. This equals 802.55. It doesn't actually say, we'll just do three significant figures again, which equals 803. Okay, so microbes. Perfect. Okay then. So, part C, with reference to the model, interpret the value of the constant A. So if we think about A, okay, and if we think about our formula, equals A, and then if we were to put 0 days to the power of B, it would just be 0, wouldn't it? If we were to put 1 to the power of B, it doesn't matter what B is, this will always be 1, so we'd just be left with A. So A is in fact the number of microbes after 1 day. So A is the number of microbes after 1 day. It's always good to bring it back to the context of the question. And you need to think about really what's going on. I always like to substitute numbers in, it makes it easier for my head. Okay, brilliant. Okay, so some of you got different numbers. I'll just quickly check the mark scheme. And yeah, so the mark scheme says that anything that rounds to 800 to one significant figure is acceptable. So if you had 849, that would still round to 800 to one significant figure. That's acceptable. If you had 750 plus, that would round to 800. Okay, so it's in between that interval. Coolio. Perfect. Okay, give question 9 a go, and then I will come and help. Okay, so this question is probably one of my favourites because it uses lots of skills. Okay, so first of all, sec 2a plus tan 2a. Okay, what do I know about sec 2a. First of all, I know it's 1 over cos of 2a. And tan, as we know, is silly calc, so this is the same as sine 2a over cos of 2a. Now, my denominators are the same, so I can add them together. So I get 1 plus sine 2a over cos 2a. Okay? Now, cos of 2a is sine squared minus cos squared, is that right?
Yeah.
Sine squared a minus cos squared a, okay? And then 1 plus, and I know that sine of 2a is 2 sine a cos a, okay? So these are the ones that I'm using so far. Now, from here, you're kind of thinking, oh, where do I go? Well, on the denominator, I can see difference of 2 squares. So I've got 1 plus 2 sine a cos a over sine squared a plus cos squared a, and then sine squared a sorry, where are these squares coming from? Sine a plus cos a, and then sine a minus cos a, okay, because that's difference of 2 squares. Okay, then from here I'm thinking, right, well, how is that going to help me? This is what I want. Okay, good news. Actually, no, this is not good news. Someone's not told me the whole truth here. Cos of 2a must be cos squared minus sine a. Is that right? Yeah. Okay, cos squared a minus sine squared a. Okay, so that means... Okay, I don't know if you have to memorize this one or it's in the formula. Do you have to memorize it or is it in the formula sheet? So this would be cos a plus sine a, cos a minus sine a. Okay, be careful for that. Right, make sure you get it the right way around. It's really important. Because as you can see here, I've got a cos a minus sine a. So cos a minus sine a. So I definitely need this on the numerator, denominator. Okay, so that's what I need. So I need to try and get rid of a cos a plus sine a, but I also want a cos a plus sine a. So they've been really sneaky here. Everyone knows that the number 1 is also cos squared plus sine squared, don't they? So I get cos squared a plus sine squared a plus 2 sine a cos a all over cos a plus sine a and cos a minus sine a. Now, we can actually factorize the numerator. Now, this is just a little trick. We know because we have squared squared and then 2 lots of them multiplied together, this is the same as cos a plus sine a multiplied by cos a plus sine a. It's cos a sine a squared if you think about it. If you had x plus y and you square it, you're going to have x squared plus y squared plus 2xy. Okay, it's using that. All of this is over cos a plus sine a bracket cos a minus sine a. Okay, we can then cancel these because there's a factor on the numerator and the denominator. So this is going to equal cos a plus sine a all over cos a minus sine a, which is the right-hand side. Therefore, proved. So then, that is part A. Part B says hence solve, okay? So we know then that because it says sec 2 theta plus tan 2 theta equals a half, that then means that cos a plus sine a over cos a minus sine a equals a half. Okay, so I'm just going to cross multiply this. 2 up here, 1 up here. So I'm going to get 2 cos a plus 2 sine a equals cos a minus sine a. Okay, I'm going to get sines on one side, coses on another. So I'm going to get 3 sine A equals negative cos A. Okay. I'm going to divide both sides by cos and by 3 at the same time. No, I won't actually. I'll just divide by cos and then you guys can see. So 3 sine A over cos A equals negative 1. If I divide both sides by 3, sine over cos we know is tan of A equals negative a third. Okay? So that is what I've got so far. Tan of A equals negative a third, which is really nice because now that I have that, were we in radians or... Yeah, radians between 0 is less than theta is less than 2 pi. Okay, so make sure my calculator's in radians. I probably should have done that first. Okay, so shift tan negative a third is 0.3217. Okay, so 0.3217 is roughly here. 0.3217. And then tan we know reflects in this line. So to find our values, I know if I start from 0 and go here, that this whole angle is pi minus 0.3217. So A equals pi shift pi minus 0.3217, which is 2.8198. 2.81989, ... I can't remember what it told me. 3 decimal places. Okay. So A equals 2.820. And then if I go round again, if I start here and go all the way round, this is 2 pi minus that. So 2 shift pi minus 0.3217 equals 5.961485. 3 decimal places, 5.961. And there we have it, between 0 and 2 pi. Okay, perfect. Okay, question 10, the last question on the paper. And any of you who do science or ever want to become a doctor, this is something, you know, this is proper applied stuff here. So yeah, I'll give you a minute and then I'll go through it. Okay, so I hope that you've taken the time to read this. I'm not going to read this out to you, so pause it if you haven't read it. Okay, so the first part of the question is really easy. We just want to use the model to find out the amount of antibiotic in the bloodstream 4 hours after the dose is given. Okay, so we're going to substitute this in. Okay, now our D in this case is 15 because the first dose of 15 milligram of the antibiotic is given. So when our time is 0, our D is 15 because that is what happens initially. So they've just come in, the time is at 0 and boom. So we're going to have 15 e to the minus 0.2 lots of 4. Okay, I'm going to put this into my calculator. 15 times 50 minus 0.2 times 4. And I get 6.7399. 3 decimal places, 6.740 milligrams. Okay, this is how much is still in the bloodstream. Sorry, I'm going to sneeze. Okay, so sorry. Okay, so after 4 hours, this is how much is in the bloodstream. It's like, you know, just under half, really. So it then says a second dose of 15 milligram was given 5 hours after the first dose has been given, using the model for the same dose. Okay. Show that the total amount of the antibiotic in the bloodstream 2 hours after the second dose is given is this. Right, so first of all, we've seen by the first one that after 4 hours, there's still some in the body. Okay? I wonder if we think when the first dose was given, how much we are now? So the first dose was given, okay? And then 5 hours later, the second dose was given. And then we want to know, plus 5, 2 hours after that, don't we? Okay, 7 hours. So if you think about it, the first dose... Sorry, right. So the first dose is still going after 7 hours, we can see here that after 4 hours, there was still just under half. So let's just, I don't know if after 7 hours, it's going to be completely left the body. Okay, so let's find out 15e to the minus 0.2 lots of 7. Let's find out if there's any left in the blood at that time. So 15 times shift e to the minus 0.2 times 7. Okay, yes, there is. So the first dose, there's 3.6989. Okay, so the first dose, we're 7 hours in and it's still going. Now, the second dose, we started, it's only been in there for 2 hours. Oh, so let's have a look. That's okay. I'm so glad you're excited. This is 10.05480. So now I can add that to 3.6989. And this gives me 13.7537, which is 13.754 milligrams to 3 decimal places, therefore shown. Okay, so really glad that I got like an oh, woohoo! Okay, no, this is fantastic because what this shows is that the drugs, this is why they sometimes, you know, on the thing they say you can only take it every so many hours because they've already calculated the rate of decrease that your blood do it based on an average person, okay? So if you think about this, you know, when you will still have some of the drug in you, the antibiotic in the bloodstream after 7 hours, but then they top you back up. Okay, so it's really important. And those of you studying to do medicine, this is a really good practical element of mathematics, which is fantastic. Okay, so that was that question. Okay, and then part C, 4 marks. Right, the next question says, no more doses of the antibiotic are given. At time t hours after the second dose is given, the total amount of the antibiotic in the bloodstream is 7.5. Show that t equals this. Okay, so what they're saying is we've got very similar to what we've just done. However, we've got t hours. So in this case where we added these two together, one was, we had our t, didn't we? And then we had, this was the t, and then we did like t plus 5 essentially. So we know then that 15, so the first dose is going to be 15e to the minus 0.2 lots of t plus 5. Okay, this is what the first dose is going to be. Plus, the second dose is given at the time of t. So 15e to the minus 0.2 lots of t. Is that right? Yep. And we want, where does this equal 7.5? Okay. Right, so now probably the hardest part of this is getting the equation. I wonder how many marks that is worth. Let me have a look. Okay, that's only actually worth 1 mark. But you need this to then solve the rest of the equation. Okay, so I'm going to zoom in. Okay, so now we need to try and get it in this form where we get a ln. So ideally I want to factorise out an e, but I've got too much going on, but that's okay. Right, so this is the same as 15 lots of e to the minus 0.2t minus 1. Okay, which is the same as, because we know that x to the power of a times x to the power of b is the same as x to the a plus b. So this is the same as 15e to the minus 0.2t times e to the minus 1. Plus 15e to the minus 0.2t. Now I said I need to factor out this e to the power of t. So I can actually factor out 15e to the minus 0.2t, and I'm going to get e to the minus 1 plus 1. This equals 7.5 because this times e to the minus 1 is this, and this times 1 is this, okay? Now you're going to see this is, now that I've factored this out, remember e to the minus 1 is just a number now. This isn't an algebraic expression. This is a number, okay? This is why I just want to get e on its own, because this to the power of t, the t is the unknown. So now I've done that, I can divide both sides by 15, so I get e to the minus 0.2t. Actually, I'm going to divide both sides by 15 and the e to the minus 1 plus 1, but I'm going to do it slowly. If I divide both sides by 15, 7.5 divided by 15 is a half. Okay, so this is a half here, right? Then I'm going to divide it by the bracket. So I'm going to get 1 over 2 e to the minus 1 plus 1. Okay, now I'm going to learn both sides because it wants it in learn. God, this is awful. Right, if I learn this side and learn this side, the e's learn is going to cancel. So minus 0.2t equals ln of 1 over 2 lots of e to the minus 1 plus 1. And then divide both sides by minus 0.2. So same as multiplying by 5. So t equals 5 minus 5 ln 1 over 2e to the minus 1 plus 1. Okay. Oh, sorry, this is now 2. I expanded that bottom bracket. Now it wants it in b plus b e. Okay. So, right then. So t equals minus 5 ln e to the minus 1 means 1 over e. Okay, I've got it. God, that took me a little minute. This minus on the outside I can bring here, so this becomes to the negative, because they don't have, it doesn't say that is a negative. Well, let's just do it this way. It's the only way I can think of to move this to the minus 1. Okay, there we go. We're getting somewhere now, which is ln to the 2e to the minus 1 plus 2 over 1, you know, because we flip it. This is great, which is 5 ln 2 over e, because that's what e plus 2, which is exactly the form they want it in, and they've got their b plus b, their b's here. Brilliant, and we've got 2, which is fantastic. Then our a must be 5. Right, that was quite sneaky, actually. When I got to here, I was thinking, how on earth am I going to have an e as a denominator? Because this technically can go up here. But it's this minus that they have. That's really naughty, okay? Got me thinking for a second. So, just to be nice, let's write it exactly how they want it. 2 plus 2 over e. Okay, where our a is 5 and b is 2. But that was a really horrible question. But hey, you know, this is the sample assessment. At least you can see a lot of everything from today. I don't know if you've noticed, is being able to manipulate stuff, you know, spotting all the patterns. So well done and good luck.